Suppose you are planning to buy fruits in the public market like apple and mango. The cost of each mango is 15 pesos, while the cost of each apple is 20 pesos. The total cost intended for those fruits should not exceed 200 pesos, and the minimum total number of fruits that you can buy is 10. How many fruits of each kind you can possibly choose to buy? This situation is just one of the real-life experience wherein we can apply the concept of systems of linear inequalities. Just stick around, for in this video, we will be discussing linear equation versus linear inequalities. I will teach you also how to graph system of linear inequalities and to determine the region of each solution set. If you are new to this channel, kindly hit the subscribe button and the notification bell, and I promise that I will journey with you in learning math lessons and concepts in an easy way. System of linear inequalities versus system of linear equations. So these are our objectives. After watching this video, you are expected to be able to differentiate linear inequalities into two variables from linear equation in two variables, illustrate and graph linear inequalities in two variables, and solve problems involving linear inequalities in two variables. In our previous video, we discussed about system of linear equations. Let us recall how are we going to graph system of linear equations. Suppose we have this equation, x plus y equals 5, x minus y is equal to 1. So to solve this system, we will do it by graphical method. So first, we are going to graph x plus y is equal to 5. Let's do this by intercepts method. Let's y be equal to 0 and solve for the x-intercept. So this would be x plus 0 is equal to 5. Our x is equal to 5. Our coordinate for the x-intercept is 5 and 0. Now let's solve for the y-intercept. Let x is equal to 0. So this is 0 plus y is equal to 5. And this is y is equal to 5. And this will give us our y-intercept 0 and 5. Let us determine the x and y-intercepts of x minus y is equal to 1. So let y be equal to 0 and solve for x. So this is x minus 0 is equal to 1. So our x is equal to 1 and our x-intercept is 1 and 0. Our y-intercept, let x be equal to 0 and solve for y. So this is 0 minus y is equal to 1. This is negative y is equal to 1. To solve our y, divide both sides by negative 1. So our y is negative 1. So our y-intercept is 0 and negative 1. So we have now the x-intercepts and the y-intercepts of the first equation and second equation respectively. So we're now ready to graph this equation in the Cartesian plane. So first, plot the x-intercept of equation 1, 5 and 0. The y-intercepts 0 and 5. Connect them. So this is the graph of the equation x plus y is equal to 5. For the second equation, the x-intercept is 1 and 0. The y-intercept is 0 and negative 1. Connect them. So this is the graph of the equation x minus y is equal to 1. The solution of the system of linear equation into two variables in graphical method. This is the point where the two graphs intersect. So in this case, these two graphs intersect at point 3 and 2. So therefore, the solution is 3 and positive 2. So if we will be checking this point, this will satisfy both equations. So let's say this is 3. 3 plus 2 is 5. So indeed, it satisfies the first equation. Second equation, 3 minus 2, and that is equal to 1. System. In this system, the equations are independent. The system is consistent because it has a solution, and the system has a unique solution, the point of intersection. So let us summarize the different scenario of the system of linear equation. The graphs could be intersecting lines, which means there is only one solution. The graph of the system could be a parallel lines. that would mean that the equations are independent and the system is inconsistent because there is no solution. It could be possible that the graph are coinciding lines, which means that the equations are dependent, the system is consistent, and the systems have infinite many solutions. By just looking after the coefficients of the x and y and constants respectively, we can also identify what type of system is being illustrated. Now let's proceed to system of linear inequalities. So the system of linear inequalities, in this video, we will be graphing system of linear inequalities into two variables, and we will also apply system of linear inequalities in two variables in solving real-life problems. By definition, two or more linear inequalities considered together form a system of linear inequalities. So a graph of an equality into two variables x and y consists of all points x and y whose coordinates satisfy the given inequalities. The solution to the system of linear inequalities into two variables consists of all points x and y that lie on the region in the Cartesian plane where the graph of the solution of each inequality overlap. So let's try to graph this first system of linear inequality, 2x plus y greater than 4, x minus 3y less than 3. So we will graph first the inequality 2x plus y is greater than 4. In our previous video, we already discussed how are we going to graph linear inequalities into two variables. So the first step is we will change the inequality to equation or equality, and we will graph this linear equation into two variables. This will serve as our boundary line. In this case, we will be graphing the boundary line by intercept method. Now let y equal to 0 and solve for x. So this would be 2x plus 0 is equal to 4, and this would be 2x is equal to 4, and divide both sides by 2 to solve for x. Our x is equal to 2. So the coordinate or the x-intercept of the first equation is 2 and 0. Now let x be equal to 0 and solve for y. So 2 times 0 plus y is equal to 4. So this is y is equal to 4, and our coordinate is 0 and positive 4. So these two coordinates are the intercepts of the equation 2x plus y is equal to 4. Now let's graph the second inequality. Change this one into an equation. Let y be equal to 0 and solve for x. So this would be x minus 3 times 0 is equal to 3. Then this is x minus 0 is x is equal to 3. So our ordered pair is 3 and 0. Let x be equal to 0 and solve for y. So this is 0 minus 3y is equal to 3. This is negative 3y is equal to 3. Divide both sides by negative 3 to solve for y. So our y is 3 divided by negative 3, that is negative 1. Our ordered pair is 0 and negative 1. So the intercepts of the first equation, 2x plus y is equal to 4, are 2 and 0 and 0 and 4. For the second equation, x minus 3y is equal to 3, are 3, 0 and 0 and negative 1. So let's graph them in the Cartesian plane. So first, 2 and 0. Second is the 0 and 4. Notice that our given inequality is 2x plus y greater than 4. There is no equal symbol at the bottom. So our boundary line is a broken line. So the broken line or the boundary line divide the plane into two half planes. So which of the two halves is the solution to the given inequality? So let's try using that test point, which is the origin. The coordinate is 0 and 0. So if this is 0 and this is 0, so this is 0 plus 0, 0. So 0 is greater than 4. Is 0 greater than 4? So this is false. So therefore, we will shade the opposite region as the solution to this given inequality. Now, let's plot the coordinates of the second boundary line. X minus 3y is equal to 3. So that is 3 and 0. And 0, and negative 1. So our given inequality is x minus 3y less than 3. So there is no equal again. So the boundary line is a broken line. So test using the test point. This is 0 and this is 0. So 0 minus 0 is 0 less than 3. 0 less than 3 is a true statement. So therefore, we will shade the region that contains the test point. This is the origin. Which region these two graphs of the solution set overlaps? So in this case, these two solutions overlap in this region. And this will be the solution set of the given inequalities. 2x minus y is greater than 4 and x minus 3y less than 3. Which means all the points that can be found in this region will make these two inequalities true. So let's say we have 4 and 2. The coordinate is 4 and 2. So this is 2. Substitute. So 2 times 4 plus y, which is 2, greater than 4. So 2 times 4 is 8 plus 2 is 10. 10 greater than 4 is a true statement. How about the second inequality? X minus 3y less than 3. If our x is 4, then minus 3 times 2, the y, less than 3. So 4, 3 times 2 is 6. So 4 minus 6 is negative 2. Negative 2 less than 3 is a true statement. So therefore, this will make the two inequalities true. So in other words, again, if you try all points that can be found in this region, will make these two given inequalities true. Example number 2. So graph each inequality. So in the first inequality, change this one into an equation and plot this one using the intercepts method. So let y be equal to 0 and solve for x. So this is 2x minus 3 times 0 is equal to 6. So this is 2x is equal to 6. Divide both sides by 2. So x is equal to 3. Our x-intercept is 3 and 0. Let x be equal to 0 and solve for y. So this is 0 minus 3y is equal to 6. So this is negative 3y is equal to 6. Divide both sides by negative 3. So our y is negative 2. The ordered pair 0 and negative 2. For the second inequality, change this one into an equation. So let y be equal to 0 and solve for x. So this is negative x is equal to 4. Then divide both sides by negative 1 to solve for x. So our x is negative 4. The ordered pair is negative 4 and 0. So let x be equal to 0 and solve for y. So this is negative 0 plus 2y is equal to 4. Divide both sides by 2 to solve for y. So our y is equal to 2. These are the intercepts of first equation and second equation respectively. So plot them in the Cartesian plane. So for the first equation, the x-intercept is 3 and 0. And so the given inequality is 2x minus 3y less than or equal to 6. So there is an equal here. So therefore, the boundary line is a solid line. So determine which region satisfies the given inequality. So use the test point, the origin 0, 0. So if this is 0 and this is 0, so 0 less than or equal to 6 is a true statement. So therefore, we will see this region. For the second equation, the x-intercept is negative 4 and 0, 0 and 2. The given inequality is negative x plus 2y less than 4. So this is less than. So our boundary is a broken line. So use the test point to determine the region of solution set. So if this is 0 and this is 0, so 0 less than 4 is also a true statement. So therefore, we will shade this region going down that contains the test point. Where do these regions of the solution set overlap? So this is the solution set of this given system of inequalities in two variables. So let's apply this concept in solving some real-life problems. Example number 3. The Maxilens want grilled chicken and tuna for dinner. Joe finds out that the chicken sells 180 pesos per kilogram and tuna sells at 350 pesos per kilogram. So how many kilograms of each can he buy if the total cost is not to exceed 700 pesos? So the problem is asking for the number of kilograms of chicken and tuna he can buy so that the total cost is at most 700 pesos. So we will now let x be the number of kilograms of chicken and y be the number of kilograms of tuna. So devise a plan. We write an inequality. So the cost of chicken per kilogram times the number of kilogram of chicken plus the cost of tuna per kilogram times the number of kilogram of tuna. Each cost must not exceed 700 pesos. So it is at most, the maximum is 700 pesos. So 180 is the cost of chicken per kilo times X, the number of kilograms, plus the cost of tuna per kilogram is 350, and we'll let Y to represent the number kilos of tuna, so times Y. At most is maximum, so this is less than or equal to 700. Simplify, so the linear inequality is 180x plus 350y less than or equal to 700. So since you cannot buy a negative number of kilograms of chicken and tuna, so we can write this one into an equality. Putting them together, so this will form the system of linear inequalities. So graph each system of inequalities. For the first inequality, 180x plus 350y less than or equal to 700. So 180x plus 350, change this one into an equation, so equal to 700. So solve for the x-intercept, let y be equal to 0. So 180x plus 350 times 0 is equal to 700. So 180x is equal to 700. Divide both sides by 180 to solve for x. So the value is 35/9, or in decimal 3.89. For the y-intercept, let x be equal to 0 and solve for y. So this is 180 times 0 plus 350 y is equal to 700. So 350y is equal to 700. Divide both sides by 350y. So our y is equal to 2. The ordered pair is 0 and 2. So these are the x and y intercept of the equation. Plot them. 3.89 and 0 is approximately here. Then 0 and 2 is here. So the given inequality is less than or equal to. So therefore our boundary is a solid line. So test using the test point to determine the region of the solution set. So if this is 0 and this is also 0, so 180 times 0 is 0. 350 times 0 is 0. So 0 less than or equal to 700 is a true statement. So we will shade this region that contains the test point. So the graph of the x is equal to 0 is a vertical line that passes along the y-axis. So greater than 0, so all allowable values are x are going to the right. So we will shade that region. For y is equal to 0, so this is the horizontal line that passes along the x-axis. So greater than 0 is going up. So we will shade that region. So the region where these three graphs of the region of the solution set overlap is the solution to the given system. So this is the solution set. Test a point that can be found in this region. So in this case, we will try 2 and 3/4. So we will apply it here. So 180, the value of x is 2 plus the value of y is 3/4. In decimal, that is 0.75, less than or equal to 700. 180 times 2 is 360. Then 350 times 3/4 or 0.75. So that is 262.5, less than or equal to 700. Add, so that is 622.5, less than or equal to 700. So indeed, this is true. So this is just one possible combination of number of kilos of chicken and tuna that Joe McSilence can buy in order that the amount will not exceed to 700 pesos. So let's have example number 4. Jason needs to buy fruits. A mango costs 20 pesos each, while guava costs 15 each. He can spend no more than 180 pesos. The total number of fruits is not to exceed 8 pieces, right? A system of inequalities that shows the various of ways he can buy the fruits. And we will graph that system of inequality. And we will choose 3 possible ways that Jason can buy the fruits. So in this case, The problem is asking for the number of mangoes and the number of guavas he can buy, and he will spend is at most 180 pesos. And the total number of fruits that he can buy will not exceed to 8 pieces. So let x be the number of mangoes and let y be the number of guavas. Write an inequality. So the cost of each mango times the number of mangoes plus the cost of each guava times the number of guavas should not exceed, so it is at most 180 pesos. The cost of each mango is 20 times x, the number of mangoes, plus the cost of each guava is 15 times the number of guava represented by y, at most less than or equal to 180. Simplify, our inequality is 20x plus 15y less than or equal to 180. So the total number of fruits should not exceed to 8. So the number of mango plus the number of guava less than or equal to 8. So putting them together, so graph each system of inequality. So for the first inequality, 2x plus 15y less than or equal to 180. Change this one into an equation. Solve for the x-intercept. Let y be equal to 0. So this is 20x plus 15y is equal to 0. So this is 0. So that would be 2x is equal to 180. Divide both sides by 20 to solve for x. So our x is equal to 9. The ordered pair is 9 and 0. For the y-intercept, let x be equal to 0. So this is 2 times 0 plus 15y is equal to 180. So this is 15y is equal to 180. Divide both sides by 15 to solve for y. Our y is equal to 12. The y-intercept, 0 and 12. For the second inequality, x plus y less than or equal to 8. Change this one into an equation. For the x-intercept, let y be equal to 0. So this is x plus 0 is equal to 8. So our x-intercept is 8 and 0. For the y-intercept, our y-intercept is 0 and 8. Graph them in the Cartesian plane. So the first equation, the boundary line, so the x-intercept is 9 and 0 and 0 and 12. The given inequality is less than or equal to, so our boundary is a solid line. Test using the test point to determine the region of the solution set. So if this is 0 and this is 0, so 0 less than or equal to 180 is a true statement. So therefore, we will shade this region. For the second boundary, x plus y is equal to 8. So the x-intercept is 8 and 0. And the y-intercept is 0 and 8. And the given inequality is less than or equal to. So therefore, still this is a solid line. So in the test point to determine the region, so this is 0 and this is 0. So 0 less than or equal to 8 is a true statement. We shade the region that contains the origin, that test point. So we will graph the x is greater than 0. So this is a vertical line that passes along the y-axis. So greater than 0 is going to the right. Similarly, the y is greater than or equal to 0 is a horizontal line that passes through the x-axis. So greater than 0 is going up. So the region where the solution set of these four inequalities intersect is this region. And this is the solution to this given inequality. According to the task, we will find at least 3 ways Jason can choose the number of pieces he will buy for the number of mangoes and guava. In this point, coordinate is 4 and 3. For the first inequality, 20x plus 15y less than or equal to 180. So 20 times x, the value of x, plus 15, the value of y is 3, less than or equal to 180. So 20 times 4 is 80. 15 times 3 is 45, less than or equal to 180. 80 plus 45 is 125, less than or equal to 180, and this is true. How about the second equation? The number of mangoes and guavas should not be more than 8. So if x is 4 and y is 3, so indeed the number of mangoes and guava combined is 7, which is less than 8. So second case, suppose in this point, So the coordinate of this point is 2 and 5. And let's try to find the cost. So 20 times 2 plus 15 times 5 less than or equal to 180. So 20 times 2 is 40, 15 times 5 is 75. Add, so that is 115 less than or equal to 180. And still, that will make the statement true. So if you add the number of mangoes, which is x, to the number of guavas, so the sum is 7. Still, that is less than to 8. Suppose we have a point here. The coordinate is 7 and 1. So, what is the cost? So, 20 times 7 plus 15 times 1 less than or equal to 180. So, 20 times 7 is 140. Then 15 times 1 is 15 less than or equal to 180. So, 140 plus 15 is 155. Still less than or equal to 180. So, the statement is true. How about the number of guava and the mango? So, the x is the number of mangoes plus 1 the number of guava. So, the total is 8, which is less than or equal to 8. And still, this statement is true. So, those are the 3 ways that Jason can possibly buy the number of mangoes and guava so that the cost will not exceed to 180 pesos. Example number 5. Each gift bag has to contain at least 15 candies and or chocolates, whose total worth must not exceed to 180 pesos. Each candy costs 5 pesos, and while the chocolate costs 12 pesos. Write a system of inequalities that shows the various of ways candies and chocolates can be combined in the bag. We will graph and we will try to find 3 possible combinations that we can put the number of candies and chocolates in the bag. So the problem is asking for the number of chocolates and candies in the bag and that the cost will not exceed to 120 pesos. And the total number of candies in this case is at least. So the minimum total number of candies is 15. So we will now let x be the number of candies and y be the number of chocolates. So write an inequality. So the cost of each candies times the number of candies plus the cost of each chocolate times the number of chocolates. The cost should not be more than 120 pesos. 5 times the number of candies represented by x plus the cost of each chocolate, that is 12, times the number of chocolates represented by y is at most. So we will use less than or equal to 120. Simplify, this is 5x plus 12y less than or equal to 20. The total number of candies and chocolates is at least 15. X, the number of candies, plus the number of chocolates is greater than or equal to 15. So putting them together, so we will form the system of inequalities into variables. We will graph each inequality. So for the first inequality, 5x plus 12y is less than or equal to 120. Change this one into an equation and solve for the x-intercept to graph this boundary line. So 5x times 12 times 0 is equal to 120. So this is 5x is equal to 120. Divide both sides by 5 to solve for x. Our x is 24. The ordered pair or the x-intercept is 24 and 0. For the y-intercept, let x be equal to 0. So this is 5 times 0 plus 12 times y is equal to 120. Simplify, 12y is equal to 120. Divide both sides by 12. So our y is 10. The y-intercept is 0 and 10. For the second inequality, x plus y greater than or equal to 15. Plot this boundary line. So solve for the x-intercept. So let y be equal to 0. X plus 0 is equal to 15. So our x is 15. This is our x-intercept. For the y-intercept, let x is equal to 0. So x plus y is equal to 15. So our y is 15. So graph them in the Cartesian plane. 24 and 0 is here. 0 and 10 is here. The given inequality is less than or equal to. So therefore, our boundary is a solid line. Test using the test point to determine the region. So if this is 0, so this is 0. So 0 less than or equal to 120 is a true statement. So we will say this region that contains the test point. So second, boundary line. So the intercept is 15 and 0. So approximately it is here. And 0, 15 is here. So the given inequality is greater than or equal to. So our boundary line is a solid line. Test using the origin. So if this is 0 and 0, so this is 0 greater than 15 is a false statement. So therefore, we will shade the other region. Another boundary line is x greater than 0. It is x is greater than 0, shade going to the right. Y is greater than 0, so shade going up. And this could be the solution set of the given system of inequalities. Choose three different ways. So first way, we'll choose this point. So this is 18 and 2. So we will plug it into the first inequality. So 5 times 18 plus 12 times 2 less than or equal to 120. So 5 times 18 is 90. 12 times 2 is 24 less than or equal to 180. Add. So that is 114 less than or equal to 120. So indeed that is true. For the second inequality, the number of candies and chocolate should be greater than or equal to 15. So 18 plus 2 greater than or equal to 15. So that is 20 greater than or equal to 15, and that is true. Another way could be x is 14 and y is 4. So substitute to the first inequality. So 5 times 14 plus 12 times 4 less than or equal to 120. So 5 times 14 is 70 plus 12 times 4 is 48 less than or equal to 120. Add, that is 118 less than or equal to 120. So still that is true. So the total number must be greater than or equal to 15. So this is also true. So let's try another way. So this is 12 and 5. So 12 and 5, substitute it here. So 5 times 12 plus 12 times 5 less than or equal to 120. So 5 times 12 is 60. And this is also 60 less than or equal to 120. Add. So 120 less than or equal to 120, still a true statement. And when it comes to the total number, 12 plus 5 is 17, greater than or equal to 15, and that is still true.
If you learned something new today, kindly smash that like button. And in the comment section, kindly send me your thoughts about this video. Please don't forget to subscribe and share our videos so that I will be able to help you learn math lessons and concepts in an easy way. See you in our next video. Thank you for watching.